In this lecture, we're going to solve, actually simplify complex fractions. In a complex fraction, that's going to be a fraction that has a numerator that is a fraction and a denominator that is a fraction. So it's going to be a fraction over a fraction, and some of them contain polynomials, which make them even more complicated. Now, what we're going to have to do is, if we have a complex fraction like we do here, we have 2/5 divided by 4/7. And the technique that we want to use is we're going to multiply the numerator and the denominator by the reciprocal of the denominator. So here we have 4/7 as a denominator, so I'm going to multiply the denominator by 7/4. And the reason I'm going to do that is you can see that 4 times 7 over 7 times 4, well, that's 28 over 28. That's just 1. So my denominator becomes 1, and so I can ignore it. And since we multiply over here the denominator by 7/4, we have to multiply the numerator by the same thing, because I'm really multiplying by 1, which doesn't change the value. So you can see in this case, then, I've got 2/5 times 7/4. And that's what it will turn out like. And notice that that's actually when you were in middle school, you learned that if you were dividing fractions, is what you did is you took the reciprocal of the second number and you change it from division to multiplication, and that's how they got that rule. So you memorize it then, and now you understand how it occurred. Because let's look again, 2/5 divided by 4/7. So technically what you do is given that middle school rule, you would take, so think of it like this, 2/5 divided by 4/7. So what you learned to do was change it to multiplication and take the reciprocal of the second number. So, and that's what I have here. So that's how I got that rule. Okay, so what we're going to do when we have polynomials that are complex polynomials, for example, notice this one down here, I have definitely have a polynomial over a polynomial. And what we need to do is we're going to write the numerator and the denominator as single fractions. What that means is, actually you can see the denominator has a fraction plus a fraction. We need to get that to be one fraction. If the numerator has multiple fractions in it, we need to get those to be one fraction. Then I'm going to use that technique of multiplying both the numerator and the denominator by the reciprocal of the denominator, which is what I have here. So let's go ahead and give that a shot. So I have 2 divided by x plus 2, and that whole thing is divided by 1 all over x plus 2 over x. So let's just focus on the denominator at this time, and let's combine this denominator into one fraction. Well, we know how to do that. That is 1 over x plus 2 over x. And so it's one rational polynomial plus another one, so we know what we have to do. They don't have common denominators. We need to make them have a common denominator. So as in the previous lesson, what we have to do is we have to find that least common denominator. And of course, in this case, that would be x plus 2 times x. So what I'll do is I'm going to have to convert this denominator into a new fraction with an equivalent denominator so that I could add those two together. So you can see that what I would have to do is, if this is going to be my LCD, that what I'm going to need to do is, if I have 1 over x plus 2, and I need to get a common denominator of x plus 2 times x, right? So I need to multiply the numerator and the denominator by x over x, and that's going to be my new fraction for that term. Now let's look at this term. And I have 2 over x, and what we said already is we need to have a common denominator of x plus 2 times x. So to get this x to be this denominator, we're going to have to multiply it by x plus 2. So the numerator has to multiply it by x plus 2 also. So 2 times x is 2x, 2 times 2 is 4. So this term and this term are going to replace those two terms with a common denominator. So, and you can, up here is where I actually added those. So I have x over x plus 2 times x, that's this term here, plus the 2 over x, which we modified to be this. So we add those together. They have a common denominator now. So here's my common denominator, x plus 2 times x. And if I take x plus 2x, that gives me 3x, and then plus 4. So my denominator, which I have over here, can be replaced by this, all by techniques we already know. Okay, now let's look at the numerator. And fortunately, the numerator, we need to have that be one fraction, and it already is. It's 2 over x plus 2. It's not added to any other terms, so that one's good to go. So what I did is I took this 2 over x plus 2, and this denominator now is replaced by the new denominator that I have here. So here is this modified fraction. And then what we need to do is we're going to take the numerator and the denominator by the reciprocal of the denominator. Well, the reciprocal of the denominator would be x plus 2 times x as a numerator, and then this 3x plus 4 would be a denominator. So there's where I'm multiplying the denominator by the reciprocal of the denominator, and I have to do the same thing to the numerator. Now I know that my denominators, when I multiply it, that's just going to become 1. So I've ignored them now in the rest of the problem, and my problem basically becomes just this numerator part, because the denominator is 1. So we can see that we have 2 over x plus 2 times x plus 2 over 3x plus 4. And now it's just a standard multiplication of rational polynomials. It's already factored. So if I multiply these together, I have 2x times x plus 2 all over x plus 2 times this 3x plus 4. The x plus 2's will cancel out, giving me 2x over 3x plus 4. Okay, so let's do an example here, and it's going to be a little bit harder. So what we have is we have a numerator and a denominator that is made up of an addition of rational polynomials. So let's start with the numerator. Let's work on it. So we have 4 over x squared minus 9 plus 2 over x minus 3. And let's go ahead and factor that. So that's going to be 4 all over x minus 3, x plus 3. That'll be added to 2 all over x minus 3. Okay, so we know we have to convert this into equivalent fractions with a common denominator. So let's go ahead and figure out what that is. So my LCD, let's take a look at the first fraction, and it's got a term of x minus 3. And the power on that is 1. So I'm going to look in my other denominators and see if that factor exists, if it has a greater power. And it does exist, but it's also got a power of 1. So I know that my LCD has to have x minus 3 to a power of 1. Now let's go to the next unique fraction. We have x plus 3 here, and it doesn't exist in the other fraction over here, so I know that it definitely has to be in there. So that's my LCD. So now let's convert these terms to new terms with these new with the new denominator. So the first term, since this 4 over x minus 3, x plus 3 needs to become a new denominator with x minus 3, x plus 3 as a denominator, we can see that it already has those terms in it. So my numerator is going to be, that first term is going to be the same. Okay, and now let's look at the second term. We have 2 all over x minus 3. It needs to become a new term with x minus 3, x plus 3 as a denominator. And so it would have to multiply by x plus 3 over x plus 3. And that's going to give me 2x plus 6. Okay, so let's go ahead and add those two together. Now that I have a common denominator, I've got 2x, and I have 4 plus 6, so that's 2x plus 10, over x minus 3, x plus 3. Okay, now let's work on the denominator. And the denominator is not too difficult. It has x plus 3 in the first term and x minus 3 in the other term. So that's pretty easy to see. The LCD of this is going to be x plus 3 times x minus 3. So I think we can convert to this new LCD pretty easily. So we've got the term x plus 1 over 1 over x plus 3. It needs to become a new term with the denominators of the denominator of x plus 3, x minus 3. So it's going to have to multiply times x minus 3 over x minus 3. Okay, so that's the first term. The second term is going to be 1 all over x minus 3. And that's going to have to multiply by x plus 3 all over x plus 3. To get me the denominator that has x minus 3, x plus 3. So now we're ready to add those two terms together in their new equivalent form. So I'm going to have x minus 3 all over x plus 3, x minus 3, plus this term in its new equivalent form would be x plus 3 over x plus 3, x minus 3. Okay, so if I add those, I'm going to have this x plus this x. I'm going to have a minus 3 plus 3 is going to be 0. So here's my denominator, simplified. Okay, so now then, okay, so one more step I'm going to take here is, see the numerator here, that really could be factored, and I didn't factor it previously. Actually, let's just add it like it is. So, actually, I am going to factor it. So what we have is if I take this 2x plus 10, and I'm going to pull a 2 out, I have x plus 5 all over x minus 3, x plus 3. And that's my numerator. So what I did already is I took 2 times x plus 5 over x minus 3, x plus 3, and I wrote it down here as my numerator. And then my denominator is 2x over x minus 3x plus 3. And I wrote that over here. So now then what we're going to do is we're going to want to take this expression and we're going to take both the numerator and the denominator times the reciprocal of the denominator. So the denominator is 2x over these two factors. So I'm going to take the reciprocal. So it's x plus 3, x minus 3 divided by 2x. I need to do the same thing to the numerator. Of course, my denominator is going to become 1. So I'm kind of going to forget about that. And my numerator, which is going to be what's left of my problem, will just be 2 times x plus 5. These are going to multiply. X plus 3, x minus 3, all over 2x times x plus 3, x minus 3, right? 2x times x plus 3, x minus 3. So let's get rid of common terms. And my end result is going to be x plus 5 over x. Okay, one more problem, and this is going to be even harder, because what we have is, notice that we have a denominator. Now the denominator is not too bad. It's already got just one fraction, but the numerator has two terms, and one of the terms is a complex fraction, or the numerator itself has an x over a denominator that has a polynomial in it. So let's work on this one. And so the first thing I'm going to do is, notice that I've rewritten it, is I just want to get this denominator that's 1 over x plus 1. I want to get that so that it's one fraction. So I'm just going to work on this term alone. and that's going to be equal to 1 over x, and I need to get a common denominator for the x, so that's going to be plus x over x. So I'm going to have x plus 1 all over x. Okay, so what I did is you can see that in this denominator that was 1 over x plus 1, I combined those terms and I have one term here. So I took the x plus 1 over x and I replaced that. So I've already done that here. So now then, the next step would be I want to add this 1 over x and then minus this term, but this term is a complex fraction in itself. So let's work on simplifying that. So what I have is x all over x plus 1 all over x. And I have one term in the denominator and one term in the numerator, so we're ready to multiply by the reciprocal of the denominator. So what I would do is, this is x, and let me move that up just a little bit. Actually, I'm going to put it over 1 so it's easy to see. So I'm going to take the numerator and the denominator by the reciprocal of the denominator. So that would be times x all over x plus 1. And of course my denominator is going to be 1. And the numerator will be x times x. And 1 times x plus 1. So that's the second term. And you can see that what I've done is since I've simplified this term, it's become x squared over x plus 1, I've replaced it. Okay, so now the next step is let's work on the numerator. So hopefully I can combine this numerator into one term. So what I have is I have 1 over x minus x squared over x plus 1. Now the least common denominator of this one, it's got an x in this term, so it's going to have an x in the LCD. And over here it's got x plus 1. So we're going to need to change this into a new fraction with equivalent denominators. And what I'm going to do is, I think we can all see that the denominator is going to be x over x plus 1. So this fraction right here is going to have to multiply by x plus 1 over x plus 1. And when I do that, I'm going to get x plus 1 over x, there's that x, times x plus 1. Okay, minus. Now let's convert this term into a new term with this as the denominator. It already has x plus 1, but it's going to need an x. That means the numerator is going to have to multiply by x, giving me x cubed. And the denominator is going to have to multiply x by x, giving me x over x plus 1. Okay, so let's go ahead and work on that. And what we're going to have is a minus x cubed plus x plus 1 all over x times x plus 1. So what I've done is I spent all that time, and all I've done is got the numerator now to where it's one term, and we're ready for the next step. So I've rewritten it, so here is my numerator now. And now we're ready to multiply by the reciprocal of the denominator. So my next step is to take a minus x cubed plus x plus 1 divided by x times x plus 1 times x over 3. Of course, my denominator is going to multiply by x over 3 also. My denominator will become 1. So basically what I'm going to have is when I multiply across, I'll have, for the denominator, I will have 3x times x plus 1. My numerator is going to be x times this negative x. Well, actually, let's just leave it factored like that. And what's going to happen is this x will cancel with that x. Okay, so what that's going to give me is that's going to give me a minus x cubed plus x plus 1, all divided by 3 times x plus 1. Okay, so what I'm going to do is just to verify that this x plus 1 is not a factor of a negative x cubed plus x plus 1. As a little side thing, I'm going to go ahead and do a synthetic division, and just to make sure. So the 0 here, if x plus 1 is a factor of this term, then a negative 1 would be out here in synthetic division. We can remember that. And I have a negative 1 for the x cubed. I don't have an x squared. I have a 1 for the x, and I have a 1 for the constant term. So let's go ahead and negative 1. Negative 1 times negative 1 is 1. Add, I get a 1. 1 times negative 1, it's a negative 1. Add, I get a 0. 0 times a negative 1 is a 0. And I add, nope, I've got a remainder. It's not a factor. So this would be my final answer. And that's it.